Hello students, today we are going to learn derivatives of implicit function. Now there are two different types of function. One is explicit function and one is implicit function. Now what is explicit function? So when you have a function of the form y equal to f of x, that is on the left side of equality sign you have a term in y and all the right side term contains only terms in x. Such expressions are always called explicit function. For example, y equal to sin x. You see, sin of x. There is no y inward here and there is no x inward here. Y equal to e raised to x. Y equal to x square plus 3x plus 5 is a polynomial. So all x terms on one side and all y terms on another side. Such functions are called explicit function. But many a times you come across in mathematics functions of the form where x and y cannot be separated. This type of function is expressed as f of x comma y equal to 0. So you can understand it by one simple example, that is ax square 2hxy plus by square equal to 0. Howsoever way you try to separate y from x, you can't. So such type of function called implicit function. How to differentiate these kinds of function is written here. Have a look. The first thing what you should do, you should try to differentiate terms in x using standard formulae, such as sin x derivative cos x, x raised to n derivative n, x raised to n minus 1 and so on. When you want to differentiate terms in y, they should be differentiated same as terms in x, except you should multiply it by dy by dx. So if it is log y, its derivative is 1 upon y into dy by dx. Understood? If it is sin y, its derivative is going to be cos y into dy by dx. Alright, after that what you do is you collect all dy by dx terms together and separate it from all non-dy by dx terms. So two things are separated, send it to the right side, and the last thing what you can do is simplify. Students, let's check the dy by dx derivative for this implicit function. You are asked to find dy by dx for this. So we will say that differentiating with respect to x. What to do? You see, a is a constant. Derivative of x square is 2x. Alright? Yes. Now, 2h is a constant coefficient. xy is uv. It's a product rule. So, derivative of xy is x into dy by dx plus y into derivative of x, which is 1. Alright, now b into, have a look, is b a constant? Yes, so please keep b as it is. Derivative of y square is 2y divided by dx. As it was explained, when you find derivative of terms in y, same as x but multiplied by dy by dx. Alright, now simplify that. You see, you can cut 2 from all the terms because right side is 0. ax plus hx divided by dx plus hy plus dy divided by dx equal to 0. Alright. Now what was the third step? The third step was to collect all dy by dx terms together. What is this? dy by dx into hx. What is this? dy by dx into dy. So let them be together. Let us send all non-dy by dx term to the other side. See, ax plus hy. Isn't that? It is sent to the other side, so it is with minus sign. Now last line is to simplify dy by dx, and this is your answer. Ax plus hy upon hx plus dy. Let's check it with another example. You see, if x raised to m into y raised to n is x plus y raised to m plus n, This is a show that, to show that and prove that dy by dx equal to y upon x. This is a standard one. If it is n, it is n plus n. So you can even attempt JW or any entrance exam problem without solving it. Answer is always y by x. Let's check out how to solve. See what is given here. You are given x raised to m into y raised to n equal to x plus y raised to m plus n. Taking log on both sides. Log on both sides. Have a look. When you take log on both sides, you see it is m times log x using all the rules of logarithm plus n times log y equal to, it is m plus n into log of x plus y. Alright, rules of logarithms are applied here. Now differentiating with respect to x. What to do? See, m as it is, log x derivative 1 upon x, there is a plus sign, n as it is, what's derivative of log y? It is 1 by y dy by dx. Alright, yes. Then m plus n as it is, have a look. What's the derivative of log of x plus y? It is 1 upon x plus y, but don't forget to multiply by the derivative of x plus y. It is 1 for x and for y it is dy by dx. Isn't it, students? Have a look. Now we will try to simplify the expression. How? You see, it is m upon x. Alright, it is m upon y dy by dx. Alright, it is equal to, have a look, m plus n upon x plus y. It is m plus n upon x plus y into 1. Let us open the bracket. Plus this m plus n upon x plus y is to be multiplied to dy by dx. Alright, so this one is a simplified expression. Now let us collect all dy by dx terms together and all non dy by dx terms to be transferred to the other side. Okay, now n upon y is with dy by dx minus m plus n upon x plus y dy by dx. Have a look. This one as well as this term are clubbed together, which is equal to, you have m plus n upon x plus y, this term, and minus m upon n. Why minus? Because a positive term when goes to the other side becomes a minus. Simplify. Keep dy by dx as it is. What happens? N into x. Have a cross multiplication. N into y. Minus my minus ny. Is that? Okay. So y into x plus y. Have a look. It is mx plus nx minus mx minus my upon x into x plus y. Have a look. Alright. Now what happens? You see x plus y here, x plus y there. It gets cut. You have dy by dx. Now nx, ny. ny getting cut. What remains is nx minus my upon y. What remains on the other side? Have a look. mx getting cut. What remains? nx minus my upon x. Don't you see that nx minus my getting cut, and the last line is dy by dx equal to, transfer this y to the other side, and what you get is the x squared. Students, let's check out one very important sum. If x raised to y is e raised to x minus y, show that dy by dx is log x upon 1 plus log x the whole square. Now you see, you know derivative of e raised to something, but a precaution to be taken in this problem is to check out what exactly asked on the right hand side. It is log x upon 1 plus log x. You must know that there is no y involved here. All the terms are x. So we should begin with x raised to y e raised to x minus y. Taking log on both sides, what you get is y log x. Log of a raised to m is m log a. So it is y log x minus y comes ahead, log e is 1, and therefore what remains is x minus y. You see, y log x is x minus y. You should not directly differentiate now, because right side contains no y term. So let us try to get y in terms of x. How? Transfer this y to left side. It is y log x plus y, and what remains there is x. Take y common. What remains in the bracket is log x plus 1, and hence you have y equal to x upon log x plus 1. You have y term on one side and all x terms on other side. You can always differentiate using with respect to x. dy by dx equal to, you see, u upon v rule must be applied. Derivative rule, u upon v, derivative of u minus u, derivative of v. Derivative of 1 is 0 and derivative of log x is 1 by x upon v square, that is 1 plus log x the whole square. Simplify. See, 1 plus log x as it is, x into 1 by x is 1, 1 getting cut, and what remains is your final answer. Students, this is another problem which explains to us whenever y equal to something which is given in infinite amount, how to solve some such types of problem. Usually, when something tends to such infinity, we are afraid of. Oh, we say, oh, such a big sum. But these are absolutely simple sums, because when you see the expression, you find it is repeating again and again with the same log x plus log x. In such cases, what you do is, let us square it. So y square, when you do it, the right side outer root vanishes. What remains inside is log x plus root of log x plus root of log x plus root of. So this one is a repetitive one which is already seen here, and very easily some such expression can be replaced by y. Because from infinite amount, if one log x is lost, nothing is lost, and therefore y square becomes log x plus y. This whole expression was called as y. Now what remains? Simply differentiate with respect to x. You know, derivative of y square is 2y dy by dx. Derivative of log x is 1 upon x, and derivative of y is dy by dx. As it was told, collect all dy by dx terms together. So let's get it on left side. 2y dy by dx minus dy by dx, 1 upon x. Dy by dx is taken common. You see, what remains inside bracket is 2y minus 1. Let 1 by x remains as it is, and finally transfer 2y minus 1 to right side, and what you get is your final answer. Friends and students, today we have covered the topic called derivatives of implicit function. If you like the video, if you feel that you have really understood, please feel free to subscribe my channel to get further notifications on remaining topics of derivatives, and please do not forget to press the bell icon and motivate me, share with your friends. Thank you.